Hello everyone, I am Venkatesan from RMD Engineering College. Today we are going to discuss problems in the topic rules of inference for quantified statements. Problem number 1. Show that for all x p of x implies q of x and p of x implies q of x. Sometimes the same question will be rewritten as show that x p of x implies q of x. Remember, if the variable x which is mentioned inside this bracket, then it will be denoted as for all x. We should denote it as for all x. So the question in the second format also will be studied as for all x, p of x implies q of x and p of s implies q of x. You can expect questions in any one format. Okay. Here, solution. The left hand side will be considered as the premises, which means your premises is for all x, p of x implies q of x, and the second premise is given as p of s. And your conclusion, what we want to prove is q of s. We are going to use the rules that we studied in the last video actually. The same rule only that I am going to implement here also. In step 1, I consider the given premises. It should be represented as rule P. That is, in step 1, for all x, P of x implies Q of x. That is the given premise that will be represented by the reason rule P. Second, using rule universal specification, we can rewrite step 1 as P of S implies Q of S. And in third step, take down the next premises also. Already two premises are given in the problem. Second premise is given as P of S. So that also represented by rule P. So when we try to simplify steps 2 and 3 using the rule that is modus ponens, what modus ponens states? P implies Q, P means the conclusion will be Q. Therefore, in step number 4, your conclusion will be Q of S. The reason, I mean the conditions that I applied as modus ponens between steps 2 and 3. Hence the proof. We continue the second problem. Problem number 2. Show that for all x, p of x implies q of x and for all x, q of x implies r of x implies for all x, p of x implies r of x. As usual, consider the left hand sides as premises. So two different premises are given here and the right hand side will be considered as the conclusion here. Hence, the premises are for all x, p of x implies q of x. For all x, q of x implies r of x. And the conclusion is for all x, p of x implies r of x. Now we are going to take on the premises one by one in the following table. Step number 1. Consider the given premise. The first premise is for all x, p of x implies q of x. Just we are taking the premises from the given problem. So it will be represented as rule P. If for all x, p of x implies q of x means using universal specification, we can rewrite this as p of c implies q of c. Step number 2. And in step number 3, I am considering the next given premises. That is, for all x, q of x implies r of x. Hence, it will be represented as rule P. And in step number 4, using the same universal specification rule, I have rewritten step number 3 as q of c implies r of c. Now try to simplify it. We don't have any more premises in the question. We had only two that we used already. Now using steps 2 and 4, I am going to simplify I am going to bring down the conclusion now. Remember in step number 2, it is given like P of C implies Q of C. In step number 4, it is given as Q of C implies R of C. By using the rule hypothetical syllogism, we can rewrite it as P of C implies R of C because hypothetical syllogism states that P implies Q, Q implies R means the conclusion will be P implies R. Hence, here the conclusion will be P of C implies R of C. But we don't want conclusion in the format of arbitrary constants. We need with respect to the variable. So we want to generalize step number 5 now. How can we generalize? Using universal generalization. So using universal generalization, I have here for all x, P of x implies R of x. Rule UG in step number 5. This is our required conclusion. Thank you.